Good afternoon. So did you guys like the theme music as we walked in? Was that a nice touch? The problem is I've told Bob that now he's set a new standard for the SETI talk, so we're going to have to figure out appropriate music for each of our series, and some of those are going to be pretty challenging. I don't know that there's been too many songs yet written about exoplanets. I'm sure they're coming, but things like that or near-Earth objects. But we'll do what we can. But in honor of Bob, we'll try to keep the music going. So again, welcome to another in the series of SETI Colloquium talks. And again, as a reminder, particularly or new information for those of you new to the series, all of our talks are recorded and made available on YouTube. You go to YouTube and you can see them. Just type in SETI Talks and you'll find them there. Our website also archives all the talks. So if you go to our website and look up the Weekly Colloquium or SETI Talk series, we have them organized by year. You can search them by topic or by speaker, and they're kind of interesting. There's now a library of over 350, probably now close to 360 lectures. So you see the presenter and the presenter's slides in these videos. So a great wealth of information on our website through the history of these talks, which now goes back to 2009. Just a couple of announcements. Again, my name is Bill Diamond, CEO of the SETI Institute. Something that I want to just give you a heads up about before I introduce Bob. But 4 weeks from today, we're going to have a very special event here for the Colloquium series. 4 weeks from today is an event that is all around Silicon Valley. It's called SV Gives, or Silicon Valley Gives Day. So this is a day where nonprofit organizations, including the SETI Institute, reach out to the Silicon Valley community. I think it now reaches up to San Francisco and beyond, but it's concentrated in this area. And there's a special website that will be set up. I think the platform is called Razoo. We will have a dedicated website on that platform all day. And of course, we'll be looking for lots of participation, including from our loyal followers of the SETI Talk series, to help us raise money for the Institute on that day. But we're going to commandeer the Colloquium session for a very fun and special event on SV Gives Day, because it happens on that Tuesday. So we're going to have a panel session instead of our normal format of a single speaker. And the panel is going to be a panel addressing the question of when are we going to first find life beyond Earth? When is that going to happen? And there may also be included in that, of course, some speculation of where and what. But the panel is going to be some noteworthy members of the SETI Institute. So Dr. Natalie Cabral, who is an astrobiologist, and she's the director of the Carl Sagan Center for Research at the SETI Institute, will be on that panel, together with Seth Shostak, Dr. Seth Shostak. Seth is our senior astronomer, and he's also the host of a radio program many of you may follow called Big Picture Science, which is a general science radio program produced by the SETI Institute and broadcast all over the country weekly and available as a podcast and download as well. Seth will be here. Mark Showalter is one of our senior astronomers. Mark is famous as having been the member of the science team for the New Horizons Pluto flyby, and Mark, as a result of working with the Hubble Space Telescope to do navigational preparations for that flyby, discovered 2 new moons of Pluto. So I think it's fair to say in his history, actually, Mark personally has discovered more moons now than Galileo. So that's not too bad. So Mark will be on the panel, and Fergal Malali, who's one of our senior scientists involved in exoplanet work and part of the Kepler team. So the 4 of them will be on the panel. I'll be hosting, and we'll be trying to get some lively discussion going and some Q&A and interaction with the audience on this rather compelling topic. So we hope you'll join us. Microsoft is one of the primary sponsors of SV Gives as an event in any case. So Microsoft is intimately involved in that day, and they have kindly as well offered to put on a lunch for all of us. So there's a little extra incentive, but then more reason, to throw money in the kitty because of the free lunch. So that'll be happening again. That is on May 3rd. Is that correct, Ann? May 3rd, Tuesday, May 3rd. So don't miss that. It's going to be a lot of fun. Also on that day, we're going to be paying tribute again because you can't pay this gentleman enough tribute. But Bill Barucki, who is here in the audience today, and the NASA scientist and engineer really responsible for the Kepler mission. We have a wonderful photograph of Bill signed by members of the Institute that we'll be formally presenting to him on that day as well. So it should be a lot of fun. All right, without further ado, let me introduce our speaker. And I can assure you of a dynamic presentation just based on, a little bit of conversation we had in the run-up to today. So it's going to be fun. Bob Richards is co-founder and CEO of MoonEx Incorporated, MoonEx. They're a privately funded lunar transportation and space resource development company striving to become the first commercial company to land on the moon. And this is a challenge only accomplished so far by 3 superpowers in history. Located at Cape Canaveral, MoonEx has contracted for 3 launches to the moon with Rocket Lab between 2017 and 2020. It's partnership with NASA under its Lunar CATALYST program, and it's one of only 2 teams in the Google Lunar X PRIZE competition with a verified launch contract. Dr. Bob Richards is a space entrepreneur and a futurist. He's co-founder of the International Space University, Singularity University, SEDS, the Space Generation Foundation, and Google Lunar X Prize competitors Odyssey Moon Limited and MoonEx Inc. Bob participated in the 2007 NASA Mars Lander mission and 2004 XSS-11 mission of the U.S. Air Force. He's a member of the International Institute of Space Law and co-chairs the Exploration Committee of the Commercial Spaceflight Federation. In today's talk, Bob's going to describe MoonEx and its plans to develop lunar resources and how this goal has set in motion technological, political, legal, and regulatory precedents that will allow humanity to rationally and peacefully, let's hope, embrace and develop the moon as the world's 8th continent. So it gives me great pleasure to introduce Bob Richards. Bob?
Well, thank you very much, Bill, and really pleased to be here. How many friends here from Ames? Wow. So we have people in the audience who have participated in real spacecraft missions. And in today's talk, I think I'll be probably weaving through inspiration of why we're doing this and the perspiration of how hard it is to actually do something. Any space mission is very hard. Landing on another world is very hard. But I can't start the talk without really recognizing kind of the honor of being here, speaking, I guess, for the 3rd time, I think, at the SETI Institute. An organization that is very close to my heart, and I've been very close to its founders, and Carl in particular was a friend and mentor, teacher. I studied both with Carl and Frank Drake at Cornell. Became Carl's special assistant for some time, and was really imbued with a wonderment of the cosmos, and in particular a desire to participate in a Mars mission, and that lifelong dream came to closure during the 2007 NASA Mars Lander Phoenix mission, where my company, at that time I was in Canada, I am a Canadian, by the way, guilty as charged, but I've been here for over 6 years now, so I think I'm maybe a welcome guest. This is the place you need to be to go to the moon or any other place in the solar system with private sector resources. So it was that honor of being involved in the Mars Lander mission. My company up in Canada provided the meteorological station based on a LiDAR technology that went on that NASA was nice enough to put a lander under and send to Mars, among other payloads. But it was very cool. It was very illuminating how difficult it was to do a lander mission. The thrill of seeing it launch, and I'll never forget that launch on that early morning at the Cape, watching the rocket. And Mars it was a very clear night at the Cape, and the stars were blazing, and you could see Mars. And the rocket, the trajectory appeared, from my perspective, to actually be pointing at Mars, although that wouldn't make sense. But it seemed romantic at the time, and that was great. And even though the landed mission was only 3 Earth months, at the North Pole of Mars, every day it was such an excitement to see the science unfold. And probably thousands of people, I guess, that touched that mission and made it possible, all working together in this cohesive microcosm of humanity at its best, right? Exploring other worlds. So that was an honor to be involved in. As an entrepreneur, the element that I was mindful of, however, was that as a government mission, that was a very expensive mission. And our little contribution, which was really a barnacle on a large ship, I watched what was a commercial technology routinely sold for maybe $30,000, about the size of a toaster, escalate into a $30 million thing before it could go to Mars. Did it have to? Geez, I'm talking about going to the moon these days for a third of the cost of that instrument that went on that lander to Mars. So maybe it didn't have to cost that much, and maybe there was another way we could do space exploration that would allow science to happen, but also on the shoulders of private sector interests, which exploration tends to be more permanent if there's economics involved. So around that mid-time frame, after we'd done the engineering work on that instrument and before it launched in 2007, I convened an international, where could you come up with a business case for an exploration mission? Besides the love of Mars, Mars didn't seem to me to be it. What commercial monetization could you talk about at Mars other than trying to monetize the inspiration? There's no practical economics of it, not yet anyway. So my attention turned to the moon, the next island neighbor in our planetary archipelago, as a likely candidate being so close. Usually when you want to open up trade to a new continent, the closer it is, the better. So in 2005, I convened the International Lunar Conference in Toronto, and with a lot of asking, we were thrilled to see over 300 delegates show up from all over the world. It was a pretty benign place to have such an international conference. And Bruce, I don't know if you were there. No, you weren't, but 300 Chinese, Russians, Canadians, Americans, Europeans, Japanese, Indians, everybody was there. And the facade of the science conference I put on was actually a fashion show for me to see if there's actually anything we could do with the knowledge of the moon at that time from a business perspective, to look at the moon for the first time from an entrepreneurial perspective and see if these two communities could come together and do something. So I was convinced the answer was yes, that there's a tremendous amount of science and knowledge to be gained from our exploration of the moon, not just about the moon, but the history of the Earth-Moon system and the entire solar system. But economically, as Earth's 8th continent, it's a place that we can aspire to learn how to become a multi-world species. It's a place that's not that far away. So in 2005, I began my personal journey. Wow, that's over 10 years ago, isn't it? To see if we could make the moon part of our economic sphere of planet Earth and move it out from the 25,000 miles it currently is in geosynchronous satellites going around the planet, where there's a couple of $1 billion of revenue happening every year, out in order of magnitude to 250,000 miles to the moon. And in 2007, my good friend Peter Diamandis announced the second space prize for the X Prize Foundation, funded by Google, just next door, called the Google Lunar X Prize, which set an incentive in mind of $20 million for the first private company who could reach the moon with a private robot, privately funded robot, take some pictures, and move around a little bit and take some more pictures. So on top of the business case, there was a maiden mission incentive, which really inspired me more. And in 2010, after having co-founded the Singularity University with Peter Diamandis and Ray Kurzweil, I discovered an enormous appetite here in Silicon Valley for what they called moonshots. So I thought, I got a moonshot. It's a moonshot. So thus begun my love affair with Silicon Valley. I moved here, lived here, raised our initial funding here, met my co-founders here, Barney Pell and Naveen Jain, and thus the story of Moon Express began 5 years after my personal story of the moon began. So today I wanted to tell you about the journey of Moon Express. So it starts about 5 years into my personal journey, and I've got a date on the screen here because if all goes well, we're now a year away from our maiden mission to the moon. So with that, we've been talking about the economic reasons why, as CEO of Moon Express, I'm the chief extraction officer. I have to extract investments from people into a very large-scale idea of eventually utilizing resources from another world to benefit our life on Earth and our expansion into space. What's the return on investment of a whole new world? How do you put it into context? Had we been Europeans in 1600s looking at why would you invest in this vast, difficult, and dangerous voyage across the Atlantic Ocean to visit this new world that had really nothing there? What are the economics of that? So coming up with the actual business case, knowing that there's great value on the moon, what value is it if you can't get there economically, or even better, bring it back economically, or do something with it economically? But establishing that there are vast resources on the moon, not the least of which is because the moon and the Earth, as people in this audience know better than I, had a kind of a mother-child co-birth relationship where elements on the moon are very similar but also dissimilar to planet Earth. But there's a lot of great minerals there and energy sources that we can utilize. So the key to all of this is really happen, thank you NASA Ames and LCROSS, with the verified knowledge that there's vast sources of water on the moon. So water to me is like the oil of the solar system, right? It's the key that unlocks the potential value in everything. So what's the value of what's on the moon? Well, to me, as kind of an entrepreneur explorer, it doesn't really matter to me what spice you're interested in, right? It's all important. But what unlocks the value of any spice, my Naveen Jain, co-founder, believes that helium-3 is, and as well know, so does Jack Schmidt, thinks that helium-3 is kind of the great resource we could utilize on the moon. My other co-founder, Barney Pell, is really excited about platinum group metals. Other people are excited about other things, but what unlocks the value of any of these is the water on the moon. Not just the stuff that supports life, but through its constituents is rocket fuel. So the decomposition into hydrogen and oxygen is the value proposition that unlocks not just the value of the moon, but it's the gateway to the solar system. It unlocks the entire solar system. We have a gas station in the sky. We don't have to take all the fuel with us in order to go to the moon, to explore, to unlock resources, and to expand outward as a species. So thank you, water on the moon. Welcome to the moon rush. Might not feel like a rush right now. To me, it feels like a rush. I'm trying to get there before others because I think there's a real economic case, and first mover advantage here is important. It's really great that NASA thinks it's important too, and selected Moon Express with 2 other US companies as a partner to develop US lander technologies that NASA could utilize from the commercial sector and expand the model that has been successful of cargo delivery to Earth orbit, like SpaceX and Orbital, to the moon, so that NASA doesn't have to develop an entire mission to answer a particular question or series of questions of science, but can actually procure rides for instruments to go get those answers on commercial missions. So the value proposition is really on the road to becoming a space resources company. We're a taxi, we're a freighter, we're in the transportation business to begin with, and that's the on-ramp to the larger vision that we have of opening up resources. Oh, and thank you for Google for sponsoring a prize that helps incentivize, and it's kind of the candle on the icing of the cake for the first mission, that we could also be awarded $20 million, which would be a fraction of the cost of doing it, but it's certainly better than not. So the moon, here's the problem as an entrepreneur. The moon is an important destination. The problem is it doesn't have affordable transportation. So not unlike SpaceX and others are collapsing the cost of access to Earth orbit, the Moon Express proposition is to collapse the cost of access to the moon. Is once we're in Earth orbit economically, it's the what then? Well, collapsing the cost of accessing the moon opens up a whole new era of opportunity. And as a transportation provider, what we're hopeful of is that a whole bunch of other ideas, maybe not unlike the analogy of how CubeSats have evolved because of the affordable access. We have thousands, tens of thousands, hundreds of thousands of students and researchers being able to utilize CubeSats very inexpensively in Earth orbit. We want to expand that capability to the moon. So it's not just maybe one space mission in an entire career, but for students, it's like, which mission are you doing this year? It's something that's repetitive and frequent. So the way we're going to start doing this, this long pathway to a large vision, is starting small with baby steps, with what we call microlanders. Landers that aren't that much bigger than this podium, but are able to deliver a substantial amount of payload to the surface of the moon that can do valuable science. And in the 6 years of Moon Express's existence, the microminiaturization of technology, the advance of exponential technologies that are dematerializing hardware into software, is exponentially increasing the amount of science you can do per unit mass volume. So the business case of Moon Express delivering instruments, sensors to the moon, is actually following that same curve because we can pack more stuff into a much tighter volume, which means a much smaller lander, which means a much smaller rocket, right? And everything starts to make sense if you start small. Until a year ago, and I'll go into this a little later in the presentation, until about a year ago, we were, even though our lander technology was shrinking, and I'll talk about the 2 technical pivots we did and 3 technical pivots that we did in the 5 years of the company, just trying to follow the exponential wave of being agile and embracing new innovations and technologies, rather than being locked into a certain way of doing a spacecraft. We were able to, that's the way that innovation and entrepreneurial companies can work, is being agile and embracing new technologies. And how those pivots have actually collapsed our prospective costs by over 10x in just the short life of the company, which began as collapsing the cost of a government mission by 10x. So we're kind of at an order of 100x less today of a lunar mission than it would have been when we started the company. When we started the company in 2010, my proposition to investors was, I think we can do this for $100 million, these missions to the moon. Now that's a lot of money, but at the government level of thinking, that's not a lot of money for a lander mission. It's a relatively low amount of money for a lander mission that does good science. And that number collapsed over time. The economics that we've been looking at, if we're able to do this, there's a number of studies out there, and never rely on the experts, of course, because they're the ones that can tell you exactly how something can't be done. But in reference to, we're not just the only crazy ones thinking that there's a market, there have been some objective studies that talk about economics in the order of billions over the next few years. Futron and the London Economic Forum did these studies, and this helps tell investors that, well, at least there's something, there's a there if we're able to solve these technical and other problems. And it's probably a good point to mention that I'm talking a lot about technology, but the risks of going to the moon are not just technical. I mean, geez, we as humans did it in the 60s with 16K computers and slide rules, right? Physics hasn't changed much in the last 40 or 50 years. So what are the risks of the private sector doing it? Well, the number one risk has always been financing. Why would anybody give part with their money to do something like this, unless it was a stunt or some sort of noble venture by a billionaire? Well, Every good commercial space company needs a billionaire backing it. That's kind of the given. It's really hard to find one, though, because they've all got their own space companies, and they're all putting their money into their own companies. So I was lucky enough to find a billionaire who was like the only kid on the block without a commercial space company. Literally, Naveen Jain. He lives in that billionaires row up in Lake Washington and Medina, and he's got Jeff Bezos is 2 docks down, and Bill Gates is 6 docks down, and it's just like that club. But he loves space, and but at the beginning of the company, just to talk about Naveen for a second, at the beginning of the company, he made it very clear to me that he didn't want to be the Paul Allen of the moon, and that reference is that Paul Allen did a wonderful thing and funded Burt Rutan. There you go, 26, 7, around the order of $30 million to take Spaceship One from a concept dream prototype to a flying spacecraft, and ultimately won what became the Lunar X PRIZE in 2004. And Paul did that for his own reasons of legacy and to initiate something amazing and inspire people and to get into the Smithsonian. But at the beginning of that venture, it wasn't about building a business. That happened when Richard Branson came in at the kind of the 11th hour and put the Virgin Galactic logo on that vehicle and said, "This is a business." Naveen said from the very beginning, "We're going to build a business here, and it's not just about the private sector equivalent of Apollo getting there and doing it. It's about just the sustainability of the business enterprise." So we've been building Moon Express based on a Silicon Valley model of investment, de-risking, creating the technology, more investment, and climbing that valuation ladder to investors all the way to the moon. So the way we have, and here's don't tell anybody this is our very secret market entry strategy, okay? And this is being filmed too, so this is our secret. So we wanted to prove that we can get there. Going for a moonshot, there's a credibility gap because it's never been done before. So, and it's very important for our partners at NASA to see that the private sector can actually do it. So our first goal was just to get there, to not get too complicated, just land on the, touching the moon would be a good thing. Touching it softly would be even better, right? So, right? So, I have, my confidence is really high that we'll be the first private sector company on the moon. It's just a question of how many pieces. And as Elon, continues to iterate his landings, and which have, a very successful one on the land, but have not quite successful yet in the water. He said at least the pieces are getting bigger, So it'll be a fantastic thing if we're able to reach the moon. I mean, the government efforts back in the first days in the 60s missed the moon entirely, right? I mean, just missed the moon for the first 5 tries. But so with the advantage of technology and the vast simulation software we have, and I don't think we're going to miss the moon as long as we get the right delta V. But it's that landing thing that's really difficult. So we want to prove we can do that. We want to win the X Prize, of course. And there's a lot of perception that the X Prize is kind of a watershed. It will be. It will be, I think, the space equivalent of the 4-minute mile. Much like Spaceship One, changed the perspective of what is possible and led to a whole new industry in private personal spaceflight, which is still emerging almost 10 years later. Despite the optimism of the early days that personal spaceflight was only a few years away from the 2004 Spaceship One double flight. But after we do that space 4-minute mile and prove that, to change the definition of what's possible, and everybody starts trying to do it too, and that'll all be great. But our next goal as a company, kind of the holy grail of our investors, is to close the business model by bringing something back. So in our space industry term, that's called a sample return mission, right? So our goal as a company is to, as quickly as we can, and it might be on our 3rd mission, that's kind of what I'm talking about. That's why we bought 3 missions, three launches between 2017 and 2020, with two rockets as option for, so 5 total, 3 contracted, 2 options, 5 total, is because I really hope that we can do a sample return mission by 2020. That's kind of the holy grail of the company. Bring something back, and it doesn't have to be a lot of something. It can be a baseball. It can be, that much. And it doesn't have to be high-grade ore. It doesn't have to be high-grade platinum group metal stuff. It doesn't have to be a whole scoop of pyroclastic stuff like was kicked up by Harrison Schmitt in Apollo 17. It just has to be some moon dust. You know, something that we just get. It's the first and only privately obtained moon dust on the planet. We think we can monetize that. It'll be special. It'll be scientifically valid no matter what it is. And we'll make a heyday out of it. It'll be a great day. So what's my third one? We need to be disruptive. We need to build disruptive spacecraft, remain agile, and in order to compete, because after we start doing this, there's going to be a whole lot of competitors saying, I can do that too, right? So it's about running faster. So continuing to develop disruptive spacecraft that continue to lower and collapse the cost of getting to the moon. Partnering with NASA. NASA's been a great partner of mine since the very first days of International Space University, and they're the best partner you could wish for, and you also don't want to have a dependency on your best friend. And I see Rick nodding here, right? So it's this, you need NASA, but you don't want to create a dependency on NASA, and you have to lead by doing, and I can say that that in this realm of the last 5 years in particular, NASA has been very responsive to our efforts and our investments. They can see that there's real money on the table. You can go to Crunchbase online and look up, that there's about $30 million of private investment in Moon Express to date. And we'll be raising, if anybody brought their checkbook, another 20 or 25 in a C round over this year. Any checkbooks? And that will be the capitalization that will get us to the moon with backup plans, with multiple rockets. When we started the company, we thought we were going to have to buy rockets from Elon, which I'd love to do, but we thought we needed a whole rocket, a whole Falcon 9. And what's changed? So let me tell you what's changed. What changed is that is that you can now buy a rocket online for $5 million and put it in your shopping cart. That's what's changed, right? Rocket Lab USA, is at the forefront, but it's not the only company that will be allowing us to buy rockets. You got $5 million, go buy a rocket. And it's a lot of money, but it's not 60 or 80. And oh my God, so we bought 3, Has it flown yet? No. Do we absolutely believe in Rocket Lab and the people behind it? Yes. Did we do a lot of technical diligence? Yes, absolutely. And if you go online, you can see that Rocket Lab went through a very important milestone of hot firing their main engines, which are completely 3D printed. All the nozzles, the plumbing, they use electric pumps. It's a very, very innovative vehicle, designed from the ground up to be low cost. So $4.9 million. We bought multiples, so you can imagine that, maybe we got a good deal. And we're an early adopter of Rocket Lab. So it's a company. Rocket Lab USA is a U.S. company. It is a U.S. launch vehicle. It is licensed by the United States. Its first flights will be out of New Zealand. So in an interesting twist here, the first private mission to the moon, which is a U.S. vehicle with a U.S. company, may actually launch out of New Zealand, which is fine. But eventually, we'd very much like to see our launches going out of the Cape, where we're located. There are some energetic reasons, physics involved, that actually make it better to launch not out of New Zealand, but it's still okay. We can still get there. So this is what we have: is we have a wonderful relationship with Rocket Lab, which I don't know how many times, what percentages of success that they're going to have on their first 1, 2, or 3 launch attempts, which will be this year. I think we'll see their first actual launch around July. I've seen the launch facilities in the southern part of New Zealand with all the lambs running away. And it'll be a very, in the realm of Mordor, off in the distance. And it'll be a very interesting thing to see. And I know they'll be successful. From our risk perspective, our launches start in 2017. So there's a couple of years here where we believe there'll be at least tens of successful launches behind us. So we're not that much of an early adopter, and we're not ready yet anyway with our spacecraft, but we will be by 2017. So, and this is why we'll be ready. I asked for how many people from NASA Ames here, and I'm glad to see many, because this company, Moon Express, wouldn't exist without our partnership with NASA Ames and our friendship with its former director, Pete Warden, in particular. We were able to enter into a relationship with NASA Ames where we were able to embrace the technology developed on Ames, the commercial spacecraft bus, which eventually became the LADI, the baseline for the LADI orbiter mission to the moon. We invested from the private sector and continued kind of the branch of the LANDI, the lander version of that spacecraft, to the point that that was our first baseline that we would launch on Falcon 9. That would be a $80 or $90 million mission in total, mostly because of the cost of the rocket vehicle. But we would embrace and learn from NASA and use those technologies that were, completely groundbreaking back in 2007, 8, 9 when they first started. And then we were able to, from our friendships at NASA Ames, evolve, as you'll see, to a vehicle at NASA Marshall Space Flight Center. And in each case, you see, we're utilizing our partnerships with NASA to utilize hardware and their assets where possible for our learning curve and develop software and learn how to fly these vehicles, where NASA assets are on the line, not our investor dollars for those. And that's one of the great advantages of a public-private partnership. These vehicles had already been built, and the value proposition had already been satisfied of why tax dollars were used to build these vehicles. So the value was there. We just came in with more private investment and liberated more value out of these vehicles with the help of NASA. So how many people remember this, right? Yeah, there you go, right? This, in that little nondescript secret building in plain view in NASA Research Park, Building 45, Area 45 as we called it. This great technology was developed at NASA Ames that, as I mentioned, became the LADI, the basis for the LADI spacecraft. But this is where we got our training wheels. We learned how to fly this. This was a cold gas system, and it was cold gas meaning there's nothing toxic. It was just compressed air that duplicated the propulsive characteristics of the rocket engines. And we were able to fly this thing in a building in a net and learn a lot from it. Then from that, in 2012-ish, we graduated, so to speak, to another NASA vehicle at the NASA Marshall Space Flight Center called Mighty Eagle. And pictured here is the Mighty Eagle with two of our staff at the time, young Mike, who I think, I couldn't even buy him a drink back then. I think he was 18 or 19 at that point. And Jim Cady, who was a very seasoned veteran of landers and spaceflight vehicles, originally from APL, who, among other things, has spacecraft at opposite ends of the solar system. He was GNC lead on New Horizons, which just gave us our incredible discoveries at Pluto, and also for the Messenger spacecraft. So, innovation, youth, experience, elder. It's been working very well. So what I'm going to show you is the result here of the partnership between Moon Express and NASA at Marshall, where we used our GNC technology on their vehicle to test fly our technology. So in this, and we were able to do several flights, and this is one flight. And the other thing about this vehicle, you'll notice that that's not an animation, that's a real robot flying in the sky with no help. I mean, this is all autonomous, right? Nobody's flying it. You can't see any rockets exhaust. Well, that's because it uses hydrogen peroxide as a fuel, so H2O2, right? Kind of oxygen-infused water. So and you can keep the volume up. It's cool. And so what's happening is the exhaust is actually superheated steam, right? So it's actually steam engine. So we became familiar with hydrogen peroxide as a fuel. Isn't that cool? The goal was to land right side up. So again, giving great confidence to our investors. It was relatively low cost to Moon Express to invest in the cost to NASA of doing these flights. And it was great for NASA that showed that it could partner with a private company and achieve a really important milestone. And based on that success, we planned funding rounds and excitement, and it all started to work. And then as exponential technology continued to advance, we were looking at the rising cost of the Falcon 9 baseline with the LADI-derived vehicle, the Common Spacecraft Bus. We had quotes coming in from traditional aerospace vendors, which were pushing the cost north of $100 million. And I was just like, how I can't raise this type of money for this first mission. So with the advance of technology, we got our engineers together and said, what is the smallest thing? Forget about the mandate to utilize NASA spacecraft bus just for a second. What's the smallest thing we could land on the moon? How could we get there the least expensively? So our engineering team got their thinking hats on, and in 2012 came up with this, which was a pretty vast pivot from our previous intent to buy a whole vehicle. We designed a vehicle that didn't need a whole vehicle. It could go as a piggyback, as a ride share on a Falcon or a similar vehicle. This, what we call the MX-1, was designed to fit in the connector ring, an ESPA-style connector ring under the primary payload, and be able to go as a secondary, presumably costing a lot less money than buying the whole rocket. So, and this was a little hot rod that, guess what, used hydrogen peroxide as an oxidizer, and an RP1 kerosene. And this vehicle is able to make it to the surface of the moon from any GTO launch. So any traditional launch that launches a satellite to Earth, this is a single-stage vehicle that can make it to the surface of the moon. It's got the energy closing capabilities. So we're very excited about this when we announced it to the world in 2013 in Las Vegas. And well, as you see, it's kind of toroidal. It's not intuitive because it had to be very short and fat. And I got a laser. And to fit under the primary. And so, but can donuts fly? Could we make this thing fly? So come the next phase of Moon Express. We did an away team down at Kennedy Space Center, established a relationship with Kennedy Space Center, and at the shuttle landing, at the end of the shuttle landing facility on the north end, there's a hazard field, or the moon field, that we'd like to call it, where another NASA lander called Morpheus was doing its last test flights, and we were able to come in and take advantage of that infrastructure and build this version of our flight vehicle and actually test it at the Kennedy Space Center. So to me, coming back to some of the inspiration, the place where some of my earliest memories of walking around the rocket garden at the Kennedy Space Center, that's what really led to the inspiration as an orphan of Apollo, wanting to be involved in these things. Now having the honor of being allowed to test my own robot in the same place, it was an amazing experience, and we had great support from NASA. So what I'm going to show you now is that donuts can fly. Thank you. All we need to do is replace that last little bit of animation with the real thing. You know, it's incidental. So some of you might have noticed that we have a strong relationship now with the Space Coast, and over the last year, we relocated the company after growing our roots and getting our training wheels and learning so much at NASA Ames and at Marshall and support from headquarters and many centers, but particularly our home at NASA Ames, to Cape Canaveral. And we've relocated the company there now. That's where we need to be to launch to the moon. And we were able to secure a launch facility, not because we're going to launch rockets, but because we have to test the launcher, which is really, a spacecraft is actually a launcher. It's going to launch from the moon one day, so it's kind of a launcher. And there's not that many places in the United States that you can actually test a rocket vehicle that hovers, takes off, lands. Space Coast is one of those places. You can go to the Wild West out in Mojave. I mean, there's a few places you can go, but to us the choice was the east coast of Florida, not the least of which was because the state of Florida and Space Florida, an organization there that incentivizes the private sector and commercial investments, gave us a great deal. And we were able to take over a historic launch complex, Launch Complex 36, which we now share with this interloper named Blue Origin. And we love our Blue Origin neighbors. If they ever want to borrow a cup of hydrogen peroxide, they just come over and knock on the door, and we say, there you go. And Complex 36 is a very large complex. It's almost 100 acres. The Blue Origin site there's an A side and a B side, just like an old record. So we've got the A side where the buildings are, and that's where our engineers are for now. And the B side is where Blue Origin will be building its initial facilities. So it's a great place to be down at the Cape. We'll be making some more announcements soon about our growth and expansion at Cape Canaveral, so stay tuned. And some of you may have noticed that that short, fat vehicle, how do you fit that in a tall, skinny shroud of the Electron? Well, we have, over the past 6 months, done another technical pivot, driven by the opportunity of a very low-cost launch vehicle. And we've been reconfiguring our MX-1 into the MX-1E with a nod to the Falcon 1E that never reached operational status, but also E for Electron. And we're very excited about that lander. We haven't unveiled it yet. I know there's a lot of people scratching their heads about how do you make it to the moon from low Earth orbit from an Electron launch vehicle? Can you really do it? Yes, you can, right? Yes, you can. We're going to I'll prove that you can when we do it, but the math works. And we believe that we can do the engineering to support the math. So we'll be unveiling what our new microlander looks like. I'll be tall and thin by that point, by the way, just to make sure it's all consistent. And we'll be showing you how that's optimized. Still same core systems, hydrogen peroxide, RP1 fuels, same avionics, basic software, sensors. It's just kind of squished up, in a reconfigured mode. I don't mean to minimize the technical challenge. Of course, this is all hard, but we'll unveil what that is very soon. And we'll be, all goes well, we have a date with a rocket in 2017 to launch to the moon. And that's only one digit away from 2016 where we sit today. So you can imagine there's a lot of aggressive and exciting things that we'll be talking about and unveiling over the next little while, all in partnership with Lunar CATALYST, where NASA is providing in-kind at this point, technology, support, advice, services. It's kind of like they come to us and say, hi, we're from the government, we want to help. And I go back to them and I say, hi, I'm from the private sector and I want to help. So it's a good relationship, and we're hoping that will evolve in the very near future to actual procurement of lunar mission services and payload delivery services from Moon Express and any others that are able to do this. So I'll close for now with that notion that our plan is to return to the moon and return investment to our investors doing it, and to return great science. There's an individual in this room, Rick Elphick, who has an instrument who I would love to send to the moon if we can just get NASA to help with that prospect, because there's a lot of great technology that's been developed already. It's 90% of the way there, or even higher, because it was an orphan payload that never flew, or a high technical readiness level back up to an instrument that did fly. And for very little money, we can adapt these instruments and send them to the moon and get great science for low cost. So I hope you'll follow our journey to the moon. We're in the final stretch. It's getting very exciting, and thank you very much for listening.
Thank you. Awesome. Thank you. All right, like I said, he's set the bar high. Now we need music and movies and so forth. But it was a wonderful talk and a very exciting undertaking and enterprise. Few things come to mind. Well, one thing is, you can always spot an entrepreneur, because entrepreneurs work really hard. They don't get much sleep and they don't have a lot of time. You might notice, if you paid careful attention, that from December 15th, 2013 to now, Bob hasn't had a chance to change his clothes. He's wearing the exact same outfit. So, you just have to work hard.
Or maybe I have very little variety.
The other thing I'd like to point out is, if you don't go to Dunkin' Donuts for sponsorship of this undertaking, I think you're missing a huge opportunity for financial support. So, and he talked about Elon Musk and things about pieces. I don't know if any of you have heard this, but one of Elon Musk's favorite expressions now is that he'd like to die on Mars, and he has said that. But what he also said was not on the landing. So this whole idea about how landings are important. It's like when you go when you fly somewhere, taking off is optional, landing is not. So anyway, a lot of tough engineering and science to do. I'd like to open up the floor to questions for Bob, and we'll pass around a mic. So we'll start down here.
Thank you for that interesting talk. To get back to the return on investment question, I'm curious.
Are you an investor?
I am not. Not at the $30 million level. I have a checkbook, but the check might bounce you all the way to the moon if I were to write. If I were to write that. So I'm curious, given international treaties and about space, what are the legal issues around mining the moon?
Great question. How much time do we have? So actually after this, talking about the no sleep, after this trip, I'll be heading over to Europe, to Vienna, to talk exactly about this with the international partners of the United States, together with the White House and the State Department, then to The Hague to talk about the same thing. And so the great news is that late last year, it was no coincidence, President Obama passed a law called the Space Act of 2015, or the Commercial Space Launch Act, depending on whether you're on the House or the Senate side, that had a Title IV called Space Resource Exploration and Utilization Act of 2015. And in that act, it recognized, codified, because I don't think it was previously unrecognized, that finders keepers in space, that those that invest in going to get own. And the precedent was set by both Soviet and US governments back in the 70s, when we brought back rocks from the moon by humans and robots, and the governments said, these are ours. And you can't steal them without being prosecuted. So they are theirs. So what we're doing is, we in the private sector will just be extending that model to the private sector, that if we peacefully go without planting a flag and claiming territory, this is not about claiming territory, this is about the open opportunity to go get things of value and economically monetize them. Not unlike if I was in the fishing business, I have a right to go into international waters that nobody owns, flying a flag under some legal regime that's recognized, putting my nets into the waters to try to catch fish which I don't own, and having a right not to be interfered with by those other ships on the horizon, perhaps flying other flags. But when I get those fish onto my deck, I own them. I mean, it's common law, right? So that type of model is what we're saying, that even though the Outer Space Treaty was largely silent, it's actually a very good document, and there's nothing that prevents this interpretation. And I think that was intentional. And private sector companies going into space, who owns the moon? Well, we all own the moon, and no one owns the moon. Those of us that go to do things on the moon or other things in space, through the United States economic model of capitalism, it will happen that way. There are other countries that have other models and will do things their own way. And I think it's a very important discussion because we have for the first time in history, we have a chance as a species to try to conquer another world without conquering each other. And I think the way that I feel an enormous responsibility in this first mission to do it right, to maybe push the envelope and not be provocative to the point of offending people, but also establish the principles that this freedom of enterprise thing is an important concept in our expansion to other worlds.
On this side?
Why not use airbags for your descent phase, like the first Mars rover? You might save on fuel.
Yeah, I wanted to use parachutes too, and then my engineers said that they just wouldn't work. So there's a number, so kind of the bouncing ball thing. So there are a number of interesting and innovative and low-cost, low-tech ways you can land on the moon. Look what the Soviets did in the first, what were they called? The one, they were also basically a balsa wood, right? And they basically hit and broke apart and opened up like a flower. I forget the name of the first missions. Very, very low tech. So it's also a very dramatic landing when you hit and bounce. And our objective is actually we're building an ascent vehicle, not just a landing vehicle. So we want to actually be very stable and be able to take off again and actually go around the moon to different places. That's part of the economics of one mission, many destinations. So we need to be able to do it many times. That's one of the reasons.
I'm curious about the value of monetizing the entertainment aspects, History Channel, some...
I've been practicing my humor.
Well, there is that, and I'm willing to pay for it in a club
I
anytime.
get most of my jokes from Seth Shostak.
Well, in that case, I might not pay as much. No, I mean, is there a significant value in what you might get out of... are you going to carry a camera? Is there any kind of video feed that you can get money out of?
So the value is in what your customers will pay for. So in the first mission, we have data. We have data from the Spaceship One, for instance. We know how many. It's about monetizing eyeballs when you're in the advertising business. It's how many eyeballs are on what my logo is or my product is, right? And how many hits do you get? So we have data now from Spaceship One that it was one of the largest watched events in space of all time. So you should be able to monetize that. On top of that, in our first mission, one of our customers is Google, who has something called YouTube, and is actually offering the $20 million is for taking images and video and broadcasting it back to Earth. So in that sense, it will absolutely be monetized, the first mission, and we will put, give me your logo and I'll put it on. I hope it doesn't look like a race car, but I mean, but we'll monetize everything on it.
Is that the fact that you're putting high-def cameras into the
Yeah.
lander as well?
Yeah, and high-def cameras 5 years ago are way different than what we mean by high-def cameras today. Now it's like, a GoPro, but before it was something much different. But just on the business perspective, the opportunity to monetize the marketing aspect, I predict, is a very rapidly, has a half-life over the first 3 or 5 missions, right? Because what happened to Apollo even, right? So the first mission is going to be absolutely, you're going to nail it on the sponsorship and marketing. Second mission, third mission, by the 5th mission, you better have another business model.
My question addresses a little bit longer term. The moon being like 1/80th the mass of the Earth, it would be easier there to build a space elevator to get to and from the surface real cheap. And so I'm thinking maybe that would be the ultimate way to get to and from the surface of the moon.
And I will applaud whatever entrepreneurial company comes up with the idea they want to build a space elevator on the moon, because I will be happy to supply them parts. So I mean, I didn't mean to be flippant in that.
Sure.
But the business model we're in is supplying picks and shovels. I'm really, and that's really where the money was made on the gold rush, was not necessarily the ones actually doing the panning, but the boots and the horses and the trailers. So that's kind of our business model at the beginning, to enable others. Sure.
So you may have just answered my question with that answer, but I noticed on your slide, on your opening slide, I was very intrigued to see these lit areas on the dark side of the moon. Are you thinking really long term and perhaps thinking colonization, or at least staff to man some of the efforts that you are going to do?
Personally, I always think long term, and the trick here is to think short term enough that you can actually have a business model. But in our there are children on the Earth today who I hope will look up in the sky at night and see lights on the moon. And it'll be a completely different perspective that people are born to. Is that it's just a fact that humanity is a multi-world civilization. There's the lights. We're not just on this. So it'll be a complete mindset change. We won't be kind of two-dimensional thinking. We'll have a three-dimensional mindset, and we'll be Homo sapiens at some point, Homo spacians at some point.
Yes, but that's not presently on your radar.
Oh, I want to put a light on the moon next year. You'll just have to have a big telescope to see it.
So have you ever thought of going the other way and putting Earth trash on the moon, nuclear waste, etc.?
Space debris is a very serious issue that is a business opportunity for us, because our spacecraft are not just built as landers, they're built as multi-purpose spacecraft, and dealing with some of the space junk problem, is a great opportunity for us. Putting it on the moon is not the best solution, but sending it away from the Earth and the moon into the sun or something like that might be a good one too.
We got time for a couple more questions. We'll go over this side first.
So I'm kind of bouncing off the very first question, but let's say you go to the moon and you find some wonderful metal and you've got a nice mine going. What prevents then somebody else from coming, another country, and saying, this is our land, get off, or pay us money? So, you haven't really talked about, you mentioned that
it's a whole other talk.
It's for
we
everybody.
touched on it here. That's right.
Is there a treaty that
Yes.
says nobody shall claim the moon, or how
Yes.
to claim it?
Yes, it's called the Outer Space Treaty. It was signed in 1967. It was formulated during a different era, where the world was worried more of nuclear annihilation, and it talked more about putting, nation states not putting weapons of mass destruction on the moon or in space, but it talked about the moon and all celestial bodies as the common heritage of all mankind, and it set out some very important principles of disallowing any sovereign states from claiming territory of the moon or any celestial body. So when the U.S. planted a flag, it was for all mankind. It wasn't, we claim this land, for the United States. So there's this interesting situation in space, which is different than on Earth, where currently the rights to land are differentiated from the rights to work the land, right? So from my business perspective, I don't need the rights to own the land as long as I have a right of non-interference of working the land that I'm working. So it goes back to kind of the old mining claims, right? Where people were working a land and they tried to not butt shoulders, for a while it was okay until people started to get really concerned. There's a big discovery, a nice treasure trove of something concentrated, and everybody wants to go there, and then you get, somebody shoots somebody, and then now we need a committee, So and then laws, evolve and so forth. So we're in the very early stages of establishing, what does that mean? And so for Moon Express, the legal regulatory aspect of it is to us a larger risk than the technical aspect. Finance, regulatory, legal, technical. So we, from the common law perspective, we will be doing things that create case precedents for the development of common law. So if we do things responsibly in a way that people are pretty much in agreement is okay, and nobody disputes it or challenges it or sues us, then that becomes a body of case law that makes it okay for other people to do it that way too.
And you really don't think some country is going to land there and say, hey, this is great. This is now our land.
That's
and
not my
your-"
problem next year. Next
Yeah.
year we're just going to be next year we're just going to be cute. We're just going to land on the moon with a little lander, not doing anything
So you're kind of
provocative.
postponing all that stuff.
But there are places on the moon that are high value that we will go to eventually, and by that time, the world will have a conversation about the way it will not interfere with each other.
Thank you.
Okay. And Margaret.
Hi, I work on planetary protection, which is part of the Outer Space Treaty. So at one point when NASA and others did the Lunar Prospector and deliberately slammed into the moon at the end of the
The
mission,
L-Cross, yeah.
to find out, I'm sorry, L-Cross, yes, to find the whether there was water
The
there.
water, yeah.
At that point, the Navajo were very concerned because culturally the moon is sacred. And so I wondered, in following
The
up
bombing
on,
the moon comment didn't help either. I
no,
know,
it
that's
didn't.
right.
It didn't. So the question is, do you think that you'll be able to enlist people who have cultural differences that play out? Since already over 100 nations are part of the Outer Space Treaty, not all of them are clearly launching nations,
Well,
and you've got
I-
other cultural areas.
Margaret, thank you for bringing that up, and I hope so. And that's one of the reasons that I'm spending a lot of time in the next month in particular over in Europe to talk to our international friends, being the Canadian peacekeeper, note, to go and talk about how the American law is exactly what other countries should be doing. The U.S. is taking steps to actually define what's responsible. And within Title IV of the H.R. 2262, that is the Space Resources Act, is enshrined the requirement of the United States to be consistent with the Outer Space Treaty. And there's language floating around in D.C. right now about what the regulatory framework is going to be for commercial companies like MoonEx or Planetary Resources or Deep Space Industries to leave Earth orbit, which no private sector company has ever done. Nobody's ever voyaged beyond the shore. And there are provisions in the Outer Space Treaty, not to go into too much detail, that require the launching state to be engaged and to be in a supervisory role because there's a liability involved, not just for what happens shortly after launch, but what could happen during operations on another world. And it gets into the whole non-interference thing. So thanks for the question. And by the way, planetary protection is absolutely one of the things that we need to address as a private sector company. And we need to look a lot like, or exactly like, what NASA would be doing or any other mission would be doing on the moon. It's a Class 2 body, as we know, but doesn't mean we don't have to be careful.
Hey, your little lander doesn't look like it has a lot of horsepower. How long does it take on a Rocket Lab launch
Who's
to
talking?
get to the moon?
Oh,
here.
thank you. I'm sorry. So the question is, our little lander doesn't look like it has a whole lot of horsepower.
Yeah, how long will it take to get to the moon on a Rocket Lab launch?
Like most answers in space, it depends. So it depends where we launch, the trajectory, how fast we want to get there. So we have a choice. We have a choice of taking the slow boat and go low energy trajectories, which means it translates into higher landed mass. Or if we want to get there faster, we can. Probably not a direct, well, I shouldn't say that. We can get there fast too, days, weeks, and if we really want to take a long time, we can take a lower energy orbit and go out, way out, like 1 million miles, and come back onto the moon. So what we're trading is time versus landed payload mass, which translates into revenue. So it depends what our customers want. Our first mission, we haven't locked in what our trajectory will be, but it'll likely not be a streak straight to the moon. It'll involve some phasing and some conservation of energy. One more? Okay.
I like the Canada arm there. Very nice touch.
Oh, yeah, I didn't put the logo on because I just didn't want to brag.
Yeah. So actually, we've been talking a lot about the fact that the lander is rather smallish right now, right? So I was wondering if you guys, if you're going to start contracting with NASA, for example, you're probably going to want to carry larger payloads, if you want to call it cargo transport. So the question I have is, what's the largest payload we could put right now as scientists? And do you have plans to make these landers larger? Like, what plans are there for
Sure.
that?
The landers are all scalable. I mean, the constraint right now is the actual shroud and energy of the $5 million launch vehicle. So we've talked about publicly that we believe we'll be able to land anywhere from 10 to 30 kilograms of payload on the moon. And even if it's a lower number, you can do a lot with 10 kilograms of landed payload on the moon. And we can answer key questions. And I would like to take a neutron spectrometer, right, Rick? Right? And that would just be, and just land in a pyroclastic area or something and just do some hydrogen measurements. And so you can do a lot for 10. If we had 30 kilograms available, I'm not sure if we could fill it on the first mission. Right? I think the supply would outstrip the demand until we've proven we can do it, and then there's going to be, it's going to be like Southwest, run for your seat. I hope. With that, I'll say thank you again. Thank you very much.
All right, thank you very much. I'm sorry to cut off the questions because I'm sure there were lots, and I'm guessing that for the right level of investment, Bob will entertain questions by email, so don't hesitate to contact him. And Bob, I do want to present you with the coveted SETI Talk Speakers mug, so let me do that without further ado.
Thank you. Thank you very much.
All right, it was
Thank you,
great
Bill.
talk.
All right.
Thanks again, everybody.